Okay, I think I get. Already on? Okay. Hello? Hello, can Webex hear us?
You're all good.
All right. All right. Thank you, Bobby. Hello, welcome for lunch day number 2 at Plugfest. On stage here, Jim Lee from Anterix, engineering department. We have set up here, you can see behind me, 3 orange pegboards with a set of vendor use cases and applications here mounted on them. And so welcome again. We're going to be doing some demonstrations here today with some of this equipment that's running over private LTE spectrum. And we'll get started. So I have on the screen here some set of slides to begin to start us off here. And the purpose of this demonstration is really to show you some of the capabilities that we have when we work with some of the vendors, their applications, to sort of help qualify them a little bit to make sure they run on 900 megahertz spectrum or private LTE spectrum, and to be able to perform some of their functions optimally, right, for our utility needs. And here we have 3 pegboards here. The ones right here next to me are we had a meter that we presented yesterday. We have an Atom from automation, pole tilt sensor. Both of these run over private LTE using a Cat M1 type technology, which is an IoT technology. It allows for better building and penetration loss. On the rest of the boards here, we have some of the more distribution automation type applications that some of the utilities will be running over their private LTE spectrum. We have a revenue meter from Schweitzer, a Beckwith Cat bank controller, and below that, a G-Orbit gateway, for a lot of private LTE signaling uses. And on the last board there, we have, if you can see it, security camera here, an access security camera that's also running over private LTE. For this one, we've actually, as I mentioned yesterday, we can do a lot of control with private LTE. And the control here is we can actually set different traffic prioritizations and traffic control, for example. But just to introduce the rest of this items here, you have a smart lighting here. It's off right now, so we'll probably turn it on later as part of this demo. And we also have a fault circuit indicator from power delivery products as well. All right, so if you look at the slides here, as I mentioned, one of the differentiators for private LTE over LTE is that because the utilities would be the IT and OT operations for their own system, they have the ability now to tag not just end-to-end on the network side, their traffic for quality service. They now can include the wireless link as well. So just a very basic high-level slide here to show that each one of these items, whether it's traffic or it's domain by OT operations or specific criticality, like in this case, what we've done is we've sectioned off the highest quality of service tagging for the Cat bank controller as opposed to the security camera with a low traffic priority. We'll see that in the demo in a sec. So again, you have that control if you are a owner of the system from a private LTE, private control perspective. This next slide here, just showing another differentiation of why private LTE is very much needed for enterprises like critical infrastructure and utilities. It's a very busy slide, but it basically shows in a diagram there end-to-end operations from a head end, a core, data center, at utilities, going through the wireless path, the APC core, eNodeBs, under a private enterprise setup, and of course you have the edge devices, the endpoints that you're communicating with. It's meant to be busy, but the basic premise of this is all those things that are highlighted in orange, yellow, or green are the new stuff that you gain if you're the operator of the system compared to if you didn't have a private use of the system. So orange is anything that's in the network layers, like VPNs or any of the configurations that you would do, that you would now have the ability to configure based on your end-to-end needs. The yellow is a user data plane, additional security features that you can add on. And of course, the most important one is now that you have all these network elements that are now part of your IT or OT setup, you have now visibility or the access to those KPIs that come out of each network element within this network. So this is just a very high-level diagram of the setup we have back here, the end-to-end plane, but we don't need to go into that today. So we'll start with the demo. We also have Guy from Automation here today, and we'll start with the first demo today, which is on a CAD M1 type technology, pull tilt sensor. So I'm going to ask him to come up, and after he's finished, then we'll go demo some of the other stuff that we have up here. Guy, please.
Good afternoon, everyone. Okay, I will need. Yeah, that can be on the table. My name is Guy. I'm the founder of Automation. Company started, time flies, 7 years ago, with the basic idea of creating an end-to-end platform that includes a hardware device with dedicated software, which is a firmware software that sits inside the device, mobile apps, and a web dashboard. Of course, we also include the storage and all the database and RESTful APIs. So it's an end-to-end solution. So it's not only the hardware itself with the sensor inside, it's also the software and the communication embedded inside. So we used to call it a pull tilt sensor, but it's actually more than that. So the automation platform has 3 pieces. The first piece is the device itself. As I speak, I'm going to also create some events. Events meaning that I'm going to tilt it and vibrate it. There is an accelerometer inside with 9 axes that can measure if the pole is tilting. It can also measure any given vibration level, very sensitive. It can be low vibration, high vibration, no matter which size of the vibration. It measures also an impact. So let's say if the pole got heated for some reason, it has a temperature sensor inside, humidity sensor inside, and also can measure the electrical magnetic field around the pole. That's an indication if the wires above the poles are energized or not. This device itself also has a connector here, which allows us to connect to an external sensor, and we're pretty much very flexible. So whatever sensor the customer is asking for, I'll give you some examples. So a current sensor that measures the current on the line. We can measure with a anemometer the wind speed if there is needed in some areas and such on. All of our computing is done on the edge. So unlike SCADA or PLC system that you're always listening to the environment and computing is done on a main brain, which is a computer or a server, we do everything here on the edge. And the reason we decided to pick up this approach 7 years ago, first of all, because the founders were only firmware engineers, and that's what we knew. But the second reason is that because we wanted to keep a standalone contained device with a battery inside, it means that this device just need to be installed and it's going to run for 7 years with the batteries inside. No need to connect it to an external power and no need to connect it to any given network because it's going to run on the CAT-M1 network that we are providing inside. So the first piece is over here. Our customer gets also an account where they can log in either from the mobile phone, iOS and Android, and of course a web dashboard. And basically the reason we provide a full solution because it's a standalone solution. So once you install the Atom, it means right now that you can go to our dashboard or to the mobile app and start to configure the device. There's two main configurations that we've seen in the last 3 years. The first one is to ask the device to sample every 1 hour, 12 hours, 24 hours, no matter what, and to send the information to the cloud. This is more to gather data and to create a baseline. But the advanced features that we are providing is also the ability to set up thresholds. That means that only when something is wrong, temperature above 140, it's tilting more than 10, 15 degrees, whatever the customer decides. The vibration is too high and takes too long. There was an high G-force on the device. The EMF went down. Whatever you want to do, you can set up those thresholds on any given time from your mobile phone or from the dashboard, and we will send the configuration directly to the device, and therefore you can know when something goes wrong. Of course, we provide email, text alert, push notifications, so if there are some people who is responsible to react fast, so they can get the notification right almost real time. It takes approximately a minute, and we're going to see from the device up to the text message. So what I'm going to do right now, we're going to run the demo together. So if that's a poll, this is our standalone device. All the sensors are already pre-activated. So we already set, Jim and I, the threshold, everything is there. So if we're going to take the device and we're going to move it more than 10 degrees, I guess it's more than 10. Yeah. Let's push it a little bit more. So that's the degrees. So what's happening right now, the device wakes up because it's checking the event, and he recognized that it's no longer on 0 degrees or 90, depends on which axis I'm pushing right now, and it's going to right now send an information to the cloud. We're going to see it right now on the dashboard. Let's also say that after the device was tilting, it was a very windy day, and it's also vibrating a lot because that's what's happening in reality. Most of the time we see tilt and vibration coming together, or impact and tilt comes together. Impact can be anything that was damaged the pole in terms of G-force. So it's either hit the pole, either there was a force from the line upstairs that created an impact on the pole itself. I cannot demonstrate EMF because there is no real EMF around the house right now. And obviously temperature and humidity, we're gonna see. So the system, how it works right now, I'm gonna go back to the camera. I already received text messages to my phone telling me that something went wrong with that device, which allows me to see the summary of, and we're gonna see it on the dashboard right now. So there was a fallen trigger. Fallen means that I created that it's going to go more than 40 degrees. So I guess I pushed it more than 40 degrees. I got an impact also, and I got also a trigger of vibration. This is exactly what we did. On the dashboard, I'm going to move over here for a second. So this is what we're going to see. We're going to see a map where this is Anterix device. They have one in New Jersey and one right over here in Missouri. So we have a GPS on the device, so we know the location of the pole. We provide 12 digits after the decimal, so it's pretty much very accurate, maybe 5 meters or, but that's good enough to find the pole. We can see that it turns to be red, the dot on the left side, because we created an event. And you get to see the events already coming in on the right screen, which the last one was, I cannot show from here, it was a falling of 62.7 degrees, so I pushed it a little bit more. If you want to go and analyze it even more, so what you can do, we have a report that shows all the events coming through. And if we want to see the behavior of the pole historically to see how long did it happen, so we can also create a graph and show the last months of what happened. As you can see, up to yesterday, there was no drama, and now everything is happening. It's because we are demonstrating everything right now. So this is basically a way to consume the data. As I mentioned before, all the historical data, even if there was no triggers such as tilt, vibration, and so on, the system will record every hour what's the temperature, the vibration, the EMF, the tilt, and the impact, and we'll upload it to the cloud every hour, so you can also have the ability to collect data. We are not doing more than 1 hour frequency just because we want to keep the battery lifetime. I'm going to show the last section of the platform, which is where you can go and configure the device. So if I pick up the UI demo device, so as you can see, we told the device, measure temperature. If it goes below 32 and 176, send an alert, vibration, impact, tilt, and EMF. And here are some examples of other sensors that we are allowed to connect as an external sensor. We can do strain to measure tension. We can do, as I said, wind speed. We can connect a leak detector if there is a need to do that. We have an IR sensor to measure distance and so on. I'm not sure if it's relevant to utilities, but that's basically external sensor that we are allowing to do. And last thing, the platform does not operate only the sensor and the information and the data that we're collecting. We are also monitoring the communication signals, if it's good or bad, and also the ability to do over-the-air firmware upgrades, which typically happen once a quarter when we are releasing a major release. So all we need to do is just overnight to upgrade the version of all of the devices, and also to monitor the sensors, the battery life, if you can see on the right side, so we can also tell what's the battery status of each device. And we are trying to sync it right with the inspection pole time. So when every 5-7 years when there is a need to inspect the pole, this is where it's going to be the time to replace the device, because it lasts for 7 years. So if you have any questions, I think that's the demo. You are more than welcome to come here and play with the device and see more information coming. But this is basically the idea. Yes, so the way it set it up on those devices is 7 years battery life. We have little atoms, part of the family, that goes to 5 years, 3 years, and we also have a coin atom that goes for 1 year. We're using a D-cell battery, a lithium battery. There is an option to connect it to external solar panel if there is a need, but we believe that in 7 years from now, the technology will be advanced and probably we're going to have a new atom. We had a request. The only so we're two founders, and we are in the firmware software engineers. Oh, Okay, so the question was if the EMF it was internal product request or we got a request from a customer. So we got a request from a co-op that wanted to know on distribution lines if the wires above the pole are energized or not. There was no need to know if phase 3 or 2 is down. It's just to know if the wires above the grid, I mean above the pole, are energized or not. We also, as a setup on wooden pole, we found out that it's okay to put one atom on every other pole. I wish we could do every pole, but we do on every other pole. And the reason is that when there is an impact or something happens between 3 poles, the atom will detect it anyway. So if there's no more questions, thank you very much.
Hey, thank you for that, Guy. That was very, very informative. Thank you. Beth, can we switch over now to my Webex?
Do you have someone to share your
Shaman,
screen,
can
sir?
you share? All right, thank you. So, that was a great presentation on automation. As you know, the technology behind that one is an IoT, a 3GPP standardized IoT module. It happens to be Cat M1 that's operating it. And so, as you mentioned, Cat M1 is great for an application like this because it has edge processing, and it just sends out the bits that is necessary back to the head end, right? And of course, Cat M1 has a power savings, as Sky mentioned, 7 years on this device in terms of battery savings. Let's move ahead with some of the other presentations. We only have a limited amount of time, so I don't know we'll be able to go through all of it. But we pulled up on the screen here sort of our demos, platforms, routers, network element manager, right? And so you can see on the screen there some throughputs that's being transferred right now. And I believe it is the video camera, right? So the next presentation here is really to take a look at QoS. So as I mentioned earlier, the quality of service ability now for the LTE signals or the platform now to be also be configured with prioritization. So in our network diagram, I won't go through all the details, but the camera was set to do video camera. So I think over here in the room, you can see the video camera feed, but I don't think you can see it online. But there's a video camera here that can look at the audience, and I'm waving my hand through it. And as I wave my hand through it, there should be on the network side, if you're an IT and OT guy, you can actually monitor the throughput to that video camera. So you can see it. It's going up to, when I move my camera, my hands, it goes up to 500, 800 kilobits per second. Again, part of this demo is really to show you the features. So as you probably already know, if you have an application running on your network on the IT side, you can operate and see all these kinds of KPIs. So the new stuff that we can see now is, Shaman just put on the screen here, is our LTE in a box private LTE system is actually an Amarasoft system. You can tell by the tabs on that. So if you click eNoB again, what you'll see here is some of the very high level KPIs that you can get from a private LTE box that you wouldn't have seen before, right? Because did you click eNoB? Yeah. So again, here you can see over the air, for the video camera, for example, the throughput that's being utilized in a live stream, right? There's other things because now you are the operator. It's a private system. You have now access to it. So again, from a visibility perspective, this is a key aspect of owning your own network. So I won't go into LTE much more than this at this point. But getting back to this demonstration here, so we have the security camera that you can see the traffic on. In the room here, you can see the live video of the audience. what we're going to do is demonstrate how quality of service can actually impact the system. The other things we have here, right underneath the screen here in front of me, is this CapBank controller, which would be normally part of distribution automation system, or maybe even further part of a Flizzr type system. And so we've actually set, through our design here, a higher prioritization in terms of its traffic compared to the security cameras traffic, right? And that may or may not be a practical approach, but for this demonstration purposes here, we wanted to show what happens when distribution automation traffic is needed, right? And so what we're going to do artificially on our system is actually create a lot of traffic on the LTE, and then we're going to see the video freeze, which we'd expect because the video camera's traffic, based on its settings, has a lower priority. So why don't we send traffic, and then on the LTE screen here, you should see, let's go back to the edge router screen. Right. So again, on the edge router screen, which is the router traffic screen here, you can see the video camera traffic going into the orders of several hundred milliseconds in front of the video camera. And then what he's going to do is actually send distribution automation traffic. And he started that, I think, and you should see the traffic on the other channel here. Right, and as you can see on the Edge Max screen here, you see a lot of blue traffic, a lot of green traffic, or the darker green traffic, and that is the distribution automation traffic that he started. And you'll notice in the audience here, you can see that the traffic actually froze on the security camera. He only ran it for about 5 seconds, and then you can see on the IT screen the video camera traffic coming back, and here as well in the room. So just a very quick demonstration, but the outcome of this is that if you have different domains or different applications or different OT type criticality for your applications end to end, private LTE has that ability now that you can tag your network's DSCP or your network's service layer directly onto the wireless carrier itself. Any questions about that? Yeah, so the question was QoS in general, is it set statically, and is there a dynamic way to change it as situation changes, like in the store mode for an OT operation? The answer is yes and yes in both, actually, right? QoS is actually many facets. The one we just demonstrated here is called QCI, which is an inherent property of prioritization of the air interface traffic itself, right? But in other times, just like in the FirstNet case, for example, you have different sets of users that have different priorities that you can set the different access priorities as well. So to answer your question, yes, if you have what they call access control, you can allow certain users, say during storm or event situations, have a higher priority access, and then you can configure it like that in your own private network. Only certain users at certain times have access, for example. And there's a few other things that can be done as well. That's good for that one. Do we want to have, let's move on to the next demo then. So as I said, we have a few minutes here. So again, on our rack here, we have a few different items here. The next demo, I think, is the FlashNet demo. So when we put out the FlashNet head-end application, I think it's on the screen here. And you can see here, well, over here you can see it because in the room we have a FlashNet. Right now it's off. And if you look at this screen here, again, a very, fully comprehensive management screen for lights. And the one that's online right now is the one that has a lamp off. I don't know if you can see it. It says lamp off here in terms of its current status. And a very quick demo here is, this demonstration is actually going into the cloud. This application is just like in the automation case, is in a server. It's routed there. So here we have the ability to now command it to turn the lamp on, and we should see the lamp turn on here in the room. Wow, that's incredible. Apparently we have full control of the hotel's lighting system here. Yeah. So anyway, so the light just turned on behind me. I don't know if you can see in the video, but the smart lighting system is actually here on the rack, and the light just turned on. Our operator actually flipped it on, and if you look on the screen here, sometimes it takes on this application a few seconds or a few tens of a seconds for the status update. And a good reason for that is this lamp it runs under another IoT technology, narrowband IoT, in the LTE world. And the narrowband IoT, just like Cat-M1 technology, has better extended range, better battery life, but it utilizes only about 200 or 180 kilobits of bandwidth in terms of resources. So as you can see on the status screen here, the lamp actually turned on. And again, we're not the experts on using this. So if you have any questions about the management platform stuff, what it can do, I can try to answer it. But again, a very typical management screen where you can control your lighting. I'm sure there's other features here where you can dim it, timers and all that as well. Any questions? All right, if not, those are the two technologies that we have, or two applications we have that are using IoT technologies. The rest of the stuff here are all on LTE, and they're all running over 3 megahertz LTE bandwidth. I think we'll go on to the next one here. We have also a fault circuit indicator that is, I believe, operational now, but if we can pull up the application on the screen, we can actually understand the status that's on right now. Right. So if you go back to the higher level screen, yeah, so again, another head-end application that kind of controls this application here. You can see that the one we have here right now, if you look on the right-hand side of the screen, it does communications to it through, as I mentioned, private LTE. Right now, it's at 158 currently in the room, and the last time it communicated with it was at 157. And it looks like its current status is connected, and everything seems to be healthy right now, which means that this demo setup we have set up here, we actually have a current loop that's plugged into the wall here, running electricity through it. And since this is a fault circuit indicator, it will detect whether there's current loss or not, current spikes or not. But we're not going to be demonstrating the current spike portion of this. I'll just basically, what I'll do is I'll flip a switch here and actually turn off the current that's running through this loop. And of course, we should see a detection on this application. But before I do that, though, the status is connected here. This thing is actually on all the time. It's an edge device. It does a lot of, real-time type analysis here at the edge. And a lot of times, the comms is actually off on this device as well, right? Only when it connects, it will actually send a signal back to the system. But currently, it's all already connected. So I'm going to go ahead and turn off the current that's on this current loop here. Oh, we should go to the other screen as well. So you can actually have the ability to go to the other screen, click on events, and you can kind of see all the historical view of the events on this. He'll be refreshing it a couple of times. So obviously it was on. It actually gave you a condition of the RF signal here too, the wireless signal here. The last time it was on was 17 amps. Let's do a refresh here and see if anything happened to it as well. Yes, and you can see right now at approximately 1:59, 2 o'clock, there was a current loss, and reading is 0 amp, because that's what we did. We just turned off the current going through this current loop. I'm going to turn it on now. Probably takes a few seconds for it to register, and we could see it re-register back onto the network. Any questions about this application? Yeah, it looks like we turn it on. A few seconds later, it says the analog level is okay now, and you're getting a reading about 17 amps going through this current loop. So not too bad for this demo platform here. Not that much power. Any questions? All right. If not, we have a few more minutes here. Again, we have revenue, Schweitzer revenue meter here that we actually have connected over our private LT network. We also have a cap bank controller. One of the things that we were able to use, I don't know, Cole's here, where we actually run an application that we use that folks use here to actually pull that meter. So let's bring up the cap bank controller polling application and see if we can pull it. So while he's getting that set up and connected, so obviously this is just a very basic level app where we can actually connect to it. It uses DNP3. It can connect to it, and we can probably pull it and send commands to it and pull it. Probably in this app, we'll be doing it very fluidly, but again, it's a cap bank controller. Probably you can set up to whatever your requirements are in terms of polling, and it will send signals back to your head-end application. So if you notice on this cap bank controller, this is one of those applications, unlike the automation, unlike the meter we have behind me, have the LTE, the connection modules embedded into the device, as is the fault circuit indicator, the street light as well. This is one of those applications where it sits in an EM box, right? You have the controller on one side, and on the door here, you have the versatility of using your own specific LTE modem capability here. So here we have a GE Orbit, but we've actually operated these on other vendors' devices over LTE. We've actually operated these on over narrowband IoT as well in the field. So the versatility for this type of application is you can actually include your preferred vendor's router if they support the Anterix ecosystem in terms of connectivity, and you can communicate through it. And of course, these kinds of devices, I'm sure you all know, they can talk serially, they can talk DNP3, they can talk Modbus, and other protocols as well. Yeah, so if you look back on the screen here, we actually are pulling that cap bank controller right now using this very basic app on our head-end device. So, I mean, this is doing something very basic, right? Doing something distribution automation, collecting data, sending it back to the head end. Typically speaking, as you all know, we're probably looking at advanced distribution management type systems where it tries to take data and actually looks at not just the cap bank control data, but maybe data from the substation over wirelessly through a revenue meter, and maybe even data from your meters, from your AMI meter system, and pulling it all together, performing some machine learning or analytics, and actually being able to help on the power efficiency side, power control side, but maybe also on the outage management side, right? Maybe some detection, for instance, this automation on a pole or something on a pole that can sense some or predictive measurements out there that says a line is about to go down or is faulting or has some issues, for example. So looking further, this also ties into why a broadband LTE system or 5G system in the future is very important for these types of applications, right? You have the low latency, higher bandwidth, more capacity, especially on the IoT side of the data bits coming back into your head-end system. Now, these are all disparate systems. This is a demo system here, but if you have an ADMS type application running on top of that, you can write your own events and your own algorithms to collect that and help you with outage management, help with other types of functions that you will need within your network. Well, I think I'll stop there. I'm just looking at my demo system. We have a revenue generator. We can also log in. Obviously, you can not only look at the user side of things, which are these data to your different head-end applications, you also have the ability to log into over the same network, the management screens of each of these applications as well. All right, any questions? If not, I'll hand it back to Bobby.